Section 1. Origins and Evolution. Before we can fully understand the complexities of modern data centers, replete with high-density racks, advanced cooling systems, and robust power redundancy, it is vital to retrace the industry's roots. In the early days of computing, data centers did not exist as discrete facilities dedicated to hosting mission-critical IT. Instead, they emerged from an era of mainframe machines, punch cards, and the first glimpses of local networking. Over time, as businesses recognized the benefits of offloading specialized infrastructure to experts, colocation facilities began to take shape. The following pages explore how data center technology, design, and culture evolved over decades, shaped by socio-economic factors, technological breakthroughs, and the relentless demand for ever more computing power. By detailing these historical tides, we illuminate the path that led to the multi-billion-dollar global data center economy we witness today. Chapter 1. Early Computational Infrastructure. 1.1. The Dawn of Computing, 1940s to 1950s. The advent of electronic computing in the 1940s and 1950s set a foundation for what would eventually become centralized computing environments. Machines such as the Electronic Numerical Integrator and computer, ENIAC, were massive, occupying entire rooms with vacuum tubes generating tremendous heat. In these formative years, the concept of servers or data centers did not yet exist. Instead, computing was carried out by large monolithic machines that often demanded specialized electrical supplies, extensive cabling and cooling solutions involving simple fans or air conditioners. Hashtag 1.1 ENIAC and its contemporaries. ENIAC, considered by many to be the first general-purpose electronic computer, housed at the University of Pennsylvania, it consumed enormous amounts of power and required a small army of attendants to keep it running. Manchester Baby. Another pioneering system, smaller in scale than ENIAC but still enormous by modern standards. Vacuum tubes, core electronic switches of the time, notoriously prone to failure and immense heat generation. Even these early systems hinted at the emergent need for specialized spaces to host computing equipment. While not yet recognized as data centers, the concept of allocating entire rooms to computing needs took root. These nascent spaces had minimal redundancy, limited cooling beyond large fans or water-based chillers, and basic security, often only locked doors or restricted campus labs. Harpshack 1.1.2 Early Cooling and Environment. Vacuum tubes generated so much heat that elaborate cooling strategies became an engineering necessity. Crude data center designs would place the computers in large open rooms with high ceilings, simply to disperse the heat away from operators. Although the technology was primitive by modern standards, many design principles, like separating equipment from direct sunlight and ensuring a dedicated power source, laid groundwork for the sophisticated data center design we recognize today. Hashtag 1.2 Mainframes and the Centralized Model, 1960s to 1970s. As vacuum tubes gave way to transistors, computing hardware shrank in size but grew in complexity and power. The 1960s introduced the era of mainframes, typically provided by companies like IBM, Burroughs, and Honeywell. These mainframes required special attention to power and cooling. Most were installed in corporate basements, large campus labs, or specialized computer rooms, often sealed to protect sensitive electronic circuits from dust, humidity, and temperature fluctuations. 1.1 The Glass House Concept. During the 1960s and 1970s, many organizations built what were colloquially known as glass house computer rooms. They featured glass walls, allowing operators and visitors to admire the state-of-the-art computing machinery without contaminating the room's environment. These spaces had raised floors, early adoption to manage cables and distribute chilled air beneath the machines. Dedicated power feeds. Mainframes required stable and clean power. Though not sophisticated by current standards, these feed lines often included step-down transformers to match the mainframe's voltage requirements. Basic redundancy. Larger installations began experimenting with backup generators or auxiliary power to prevent disastrous downtime. 1.2.2 IBM 360 in the standardization era. Among the most influential mainframe lines was the IBM 360, introduced in 1964. This family of systems standardized hardware and operating systems to an extent never seen before, making it easier for businesses to commit to centralized computing. With standardization came more systematic approaches to room design, physical security, and staff specialization. For instance, organizations recognized the need to manage temperature meticulously. Small data center design guides or internal memos specified recommended ranges between 68 and 72 degrees Fahrenheit, echoes of which remain in modern ASHRAE guidelines. 1.2.3 Early local networking and the seeds of communication. In these mid-century decades, local networking advanced from direct terminal connections to coaxial lines. Basic forms of local area networks, LANs, started to appear within corporate campuses or government labs. Although most data processing remained highly centralized, the seeds for wide area networks, WANs, were sown. As bandwidth demands escalated, so did the need for specialized connectivity rooms and intermediate distribution frames. This eventually foreshadowed the carrier-neutral approach that would power colocation data centers. 1.3. The rise of client-server and microcomputers, 1970s to 1980s. The next revolution in computing came with the microprocessor and the shift away from purely centralized mainframes. In the 1970s and 1980s, mini-computers and client-server architectures challenged the single, monolithic hardware approach. Although DEC, Digital Equipment Corporation, Wang and others championed smaller mini-systems, the notion of a dedicated room for computing persisted. Many organizations still wanted reliable, controlled environments where these smaller machines could run optimally. 113.1 Client-server paradigm, distributed computing. Instead of a single mainframe supporting all tasks, multiple mini or microcomputers could divide workloads. Ethernet. Robert Metcalfe's invention at Xerox PARC revolutionized how machines shared data, eventually enabling IP-based local networks. Departmental servers. The 1980s saw entire departments in large organizations adopting their own servers, leading to scattered server closets with minimal oversight or consistent standards. Despite the decentralized approach, the largest corporations and government agencies still ran mission-critical tasks on powerful mainframes housed in specialized facilities. Over time, the concept of data center design was refined, featuring better cable management, more advanced fire suppression systems, and improved cooling architectures. Hashtag 1.3.2 Early commercial hosting experiments. A handful of companies saw an opportunity. What if third-party providers could house these departmental servers or mainframes more efficiently, offering cost sharing and economies of scale? While overshadowed by on-premises footprints, the seeds of commercial hosting and time-sharing were planted. Some organizations recognized that paying for partial server time was more economical than purchasing, installing, and maintaining their own hardware. This notion would later crystallize as colocation and cloud hosting.